Hello and welcome to Broadcast Focus. My name is Russell Trafford-Jones and thanks for joining me for another conversation. That's what we do here. Friendly chats with people behind the broadcast and media and entertainment industries. Just wanted to add a quick thanks here to everyone who's subscribed so far. Your contribution to the channel is very much appreciated. And today I'm joined by Lee Hunt, Director of Hardware Engineering from InSync Technology. Welcome to the show, Lee.
Good afternoon, Russell. Nice to meet you.
It's good to have you on the show. And for those who don't know, it's probably worth starting off telling us what InSync does.
Yeah, so InSync Technology, we develop high-quality standards conversion, motion compensated frame rate converters from box products to line cards, etc. So that's our specialty. That's what we're very good at. A lot of tier one premium material goes through our equipment, and you probably, most of the stuff that's been broadcast and videos gone through our equipment. So very proud of what we do for InSync Technology. I'm Director of Hardware Engineering, and I head up the engineering team and come up with the product ideas and bring that product to market. The most recent product is the MCC HT2, which is probably one of the best hardware standards converters you can buy. So pretty proud of that product, and it's both OEM branded as well as our own branded products. So we cater for all.
Wherever somebody needs frame rate conversion, you're there. On the second episode of Broadcast Focus, I chatted to Gerard Phillips, and we talked about how he started in flight simulators before he got into broadcast, but he also worked for Snell, because you've worked with Gerard as well, because you've been in InSync for a long time, but you've done lots of things beforehand. What is it that kind of got you thinking about broadcast first? You didn't come straight into broadcast and you went through another industry first?
No, yep, very similar to Gerard. I mean, I was always a bit of a engineer at heart, a bit of a tinkerer, in the school days. I did CD technology, and I loved electronics. I'd be designing a little PCB with ferric chloride and, the old black tape and stuff, and do a little stable circuit using transistors and capacitors and resistors. And I don't know, I just had the buzz. I just loved electronics and used to buy the electronic magazines. I guess you talk to any real, old engineer, they'd all remember the old electronic magazines that used to come a little printed circuit board on the outside. And you think, yes, can go and buy the components and put it together and make something. And you get a lot of a sense of achievement of creating something, building something from scratch and actually seeing it work. And that's what I had a real passion for. And obviously did pretty well at school with CD technology, and then moved on to a more practical engineering national diploma at Harvey College. Mm-hmm. So I did that for 2 years and then moved on to do the high national diploma, which it was less theory and more practical, but that's, bit of both, which I really enjoyed. Yeah. So again, I did really well at college. I got an IEEE award, being, one of the top graduates at the time. So yeah, little medal. So I was pretty tough with that. And my first real job after that was working for Delarue, not related to broadcast whatsoever. So I was a testing commissioning engineer working on their cache sorting system. Very similar to, I think, Gerard and worked at Delarue. And I was there just testing their machines before they went out. And
the machines were they?
They were the humongous machines. They were like the size of a room. And you had multitudes of boards, sensors, circuit boards, etc. And you'd basically load up the cache on one side. It would then get filtered through the system, go through all the different sensors to detect holes, tears, even all the imaging on the notes and the cache notes. This is all cache,
no coins,
and you'd either have a pass or fail, and that was it. And I had to then tweak all the sensors, and if the sensor didn't work, you had to find out why that sensor didn't work, and if it was down to the circuit board, you just replace the board. There was no, you didn't have to go down a component level to test to see what was wrong with the board. But yeah, so it was, I mean, it was an okay job. It got me into, I guess, the test side of a job, and but it never really didn't excite me. I didn't go to work buzzing. I'm going to go and test another machine today. It was
surely.
I'm not. I mean, the amount of money that went through my hand. You had security guards. carrying this big bag of cash, like hundreds of thousands of pounds, and you were then trusted with that cash to go through this machine to test it. And yeah, it was, and you were boxed in. You were literally in this closed environment. You had no windows, and it was under lock and key. And you were not, once you're in, you couldn't get out without going through security measures. Obviously, handling money and real
Sure.
money. It was, yeah.
But what,
Um,
just to count it, or you said it was to find.
It was for both. It counted it, and it also tested for fake money and whether or not it could be recycled, as in reused.
Okay.
So if a note was beyond, if there was too many tears, too many holes, then it would then get. There was this shredder machine, so you'd literally shred the cash. Yeah, do you know what I mean? And it needed to know exactly how much money was shredded at the end. But so yeah, that was the best part of the job. Watching all this money just get shredded to pieces and then get binned or burnt or however it got disposed of at the end. So I did that for about a year. And while I was there, they had this invest in people scheme. So I started my degree. So I did a part-time Bachelor of Science honours degree when I started Delarue, and which was great. That got me my foot in the door of doing a degree. And a few months later at Delarue, I managed to get a job at Snell and Wilcox, and just by chance. And my dad, who was he was a telecommunications engineer, and he was working at Durford Mill, and he was talking to one of the engineer and one of the high guys there, and they said that they were in a massive recruiting spree at the time, and it's all to do that with all the MPEG funding that Snell and Wilcox got it back in the day. And this was back in 1996. We're talking about a long time ago. So they were saying they're looking for people and engineers. And my dad said, "Why don't you put your CV in? What can you lose? Just to see what happens." So I said, "All right then." So I wrote up a CV, sent it in to them, and I got an interview the following week, and got interviewed at Durford Mill. They said that they didn't need anyone at my level at them, because I was on a sort of a junior level, and because I didn't have all the qualifications that they needed at the time. They needed someone with a degree at the time. So I then got an interview up at List Mill with the Barry Flanagan's crew up there, and he snapped me up, and he recruited me. A month later, I joined as a junior hardware engineer, designing rear modules for the IT modular system. So, and that kind of got me into schematic entry, PCB design, very low level, very basic electromechanical stuff.
Was that similar to the kind of component stuff you did with the magazines and stuff at school, or was that just kind of, apart from the fact it was electronics, it was totally different?
It was a bit, I guess it was similar. They were basic 2-layer boards, with a BNC connector and some capacitors and a surface mount connector. But you had to make sure, because at the time it was 270 megabits for SD video going through. So it was, back in the day, it was high speed electronics. So yeah, but it was fun. It got me into real engineering, doing schematics and PCBs and using DOS CAD-Star, which was, we won't go there, but that's where my route started in broadcast, and I was then given the opportunity at the time, after I'd been there for a year, because I'd worked hard. Barry was really happy with what I was doing, and he gave me the opportunity to actually develop my own IQ modular card for the Snell and Wilcox modular range. So that's where, and that was to do digital audio processing. So that was a family of line cards where you put in AES audio and sample rate, convert the audio, and do audio delay and audio synchronization, audio processing, gain controls, tone generation, etc., etc. And there was an audio router and just a mix of different audio processing cards, A to D converters, D to A converters, etc. At the time, I was really chuffed to be given an opportunity, for coming in at that sort of very low level, to given the responsibility to develop a product range.
How did you bridge that gap when you joined and you're kind of doing backplane stuff? How did you kind of skill up there? Was the training?
Yeah, I mean, there was a number of engineers that were there at the time that were really good mentors. if you had any problem, or, they would talk you through a problem and you would come up with answers or solutions, and they'll talk you through it, and they had time. I think it's important to have time with engineers to go through these problems and work through the problems. And that really, really helped, really, really helped, and gave me confidence in what I was doing. And that's kind of how I learned it. And reading textbooks about digital electronics. And so there was plenty of training on hand on the job. That's kind of how I upskilled.
Yeah, that's good, because as you say, it's quite a difference between, PCB, which is just getting some DC to go around some resistors and stuff, to dealing with hundreds of megahertz, and the preciseness you need for audio as well.
Yeah, and it was all using FPGAs. So this was like 8 Altera 8K devices for tiny little FPGAs with like 300 logic gates or something. 300 logic gates. You think about it now, you'd talk about millions of logic gates, but this was like really, really low resource technology, and you had to be really efficient in what you were doing because you had so limited resource. You didn't have the luxury of hundreds of thousands of gates. You then learn how to optimize using gate resource and the stuff that you were doing.
It's interesting. When I was going through the BBC scheme, they got us doing logic gates, physically building stuff up with the TTL logic chips. And you see how you don't need that many before you get kind of a complex system that can do some stuff. So if you think about it from that perspective, gate, 500, 800 gates, we could do a fair amount of stuff with that. But of course, when you're dealing with that much video and, do calculations based upon it, then it doesn't go very far, I guess.
It doesn't, no. But with the audio, I mean, nowadays you can just chuck parallel audio into an FPGA and it just munches it up and do a lot of DSP processing, etc. But when you have got a very small device back then, it was all serial digital audio, and you're doing serial processing of audio with LSB fast, and then lots of bit manipulation just to do what you needed to do in the most optimal way. But it's that's not thought of much anymore, I think, because we've got so much resource now. It's time to market.
Yeah. It's funny though, because we used to do video in parallel, and then that was seen not to work anymore, so that went to serial.
Yeah,
because we keep it all synchronized.
Yeah.
I can't not bring this up since you mentioned CAD stuff.
Oh yeah. Oh my goodness me. Yes, that is it. Gosh,
it looks like it would be really difficult to use, but I don't know.
It was. I did have a mouse. The tricky bit was the tools nowadays are really powerful. PCB tools for PCB checking, layer checking, continuity. Where that was all done by eye. You'd have to, like plain circuits or plain short circuits, or whether or not a track from the left of the board ended up to the right of the board. You'd have to. It was the design rule checking was the DRC just was in its infancy. So there was a lot of board respins, as you can imagine.
You spent a long time looking at the screen, I guess.
Yeah, and a lot of times looking at the screen. Yeah, so the tools are a lot more powerful than they were back then. But yeah.
So you designed an audio series of boards.
Yep.
Yeah. And then with increasingly better FPGAs, what came next for you?
So I concentrate mostly on audio products, and then there was a product range that did video. There was a platform name called SD-Bass, so that did both video processing, so audio de-embedding, embedding. So I got involved in that, and audio processing and mixing, and kind of doing a lot together. And then like frame synchronization, frame stores, video changeover module, but it was all same frame rate in and out, like a TBC with time-based correction and stuff. Basically taking in unstable sources and then making them stable. So both SDI and composite video. So there was a Philips decoder on there that had just it was just a line comb decoder. So you'd come in, you'd decode it to baseband video and frame synchronization, and then re-encode it on the back ends, or go at SDI. So you could go at SDI and composite video or YC on the output, and do all that, and maybe some proc amp control stuff, RGB controls or luminance controls, black level controls, etc. and do the audio side of things as well. Extracting the audio, resampling the audio to match the output, synchronization clocks, and then re-embed it back into the SDI stream. So that was the next family of products that I was involved in, which did really well again. So that was kind of the end. And then we all left or got made redundant, unfortunately. And 4 of the engineers started up InSync Technology, and I interviewed for the role of a design engineer and got the job. So it was basically 4 founders plus me as an engineer. So I was a principal design engineer. So I'd gone from obviously junior to design engineer to senior engineer to now principal design engineer. That's how I started my career with InSync, and that was to continue doing some other projects that they were working on and developing box products. So these are box converter products, and these are little half view products. Again, TVCs that starting, time-based correctors to start off with.
In a rack, or they could be just like thrown on the back of a desk or something.
Yeah. So they could be desk mount if you wanted to. It was called InSync's IFP, InSync's first product. That was the product family name that we called it at the time, and that was doing analog and SDI video and audio as well. So I'd get more involved in the audio side again. And then we did another product after that to do our first standards converter. So that was our first generation of motion comp standards converters.
Just go back to Snell Wilcox. That last product you mentioned, is that when you were working with Gerard?
So I never worked directly with Gerard. I mean, he was working at Durford Mill at the time, and I was at List Mill, but we knew of each other, and we were good friends. So we would socialize together with the group of us and go snowboarding and skiing with each. Joe and I've got plenty of stories of when we used to go snowboarding and skiing and stuff, and that was great. It was a great social environment to be in. There were a lot of young engineers. We all gelled really well, and we worked very hard in what we did, and we had the social element as well, which is key. It was really good, and it helped bond the teams together. And
I guess testament to that, the four of them were good enough friends that they decided to set up a company together.
Exactly. There you go. Yeah, exactly.
But how has the hardware technology changed since you first drafted in as principal to now?
I think the biggest change is the FPGA technology. Certainly over the last, I've been at InSync for 21 years now, and the size of FPGAs have grown exponentially. We're working with million gate devices now, whereas when I first started at InSync, it was a few 100,000. So it's like you've got 10 times the amount of resource now that you had to hand back then. And the power has remained the same, because obviously the die shrinks, and you can get more technology onto an FPGA than you could 10 times the amount, and the power consumption hasn't changed.
What about the circuits or the whatever you need to support the FPGA? I mean, is it effectively a computer nowadays, or?
I think it's simplified a little bit, I guess. Depends how you look at it. So, I mean, it's just an FPGA with DDR memory and SDI in and out, and a host CPU or processor that does the FPGA loading and does the control and status monitoring and loads up a web control and the like. So I think the basic architecture is quite simple, really. You just want to get everything into the FPGA and do everything in the FPGA, and that's kind of what we do, and that's what we're very good at, is the stuff that happens in the FPGA. And we've got some very talented engineers here with tens and tens of years of broadcast video experience. It's amazing what you can squeeze into a little FPGA, like 30 watts of power or something in an FPGA with lots of the periphery bits around the outside. It's pretty amazing.
In your 20 years there, 21, did you say?
21 years, yeah.
It's not a large company. Yes, you've had to do a lot more than just electronics and FPGA design.
Yeah, it's because we are small. I mean, you are involved in every side of the company, from business side to the engineering side to the development, going to trade shows, speaking to customers, finding out their requirements, writing product proposals, business cases, bringing that product to market, running an engineering team. There was a period in my career where I was in charge of production management, procurement, taking in sales orders, or generating sales orders to buy components, doing the purchasing and production side and managing that side of the company. I enjoyed that part of it. But yeah, you just have to chip in everywhere in the company, and from doing the recycle bin or something, to buying the biscuits.
I don't know how big Snow Wilcox was when you were there, but I'm sure it's a bigger company than InSync at the moment. But I think that's one of the things about broadcast. You don't really need a large company to do a lot of good things, but it's a totally different feeling as a company than if you're in one with 300 or 1,000 or 1,000 people.
Yeah. I mean, I guess one of the key benefits of InSync is we're employee owned. So every single person that works for InSync is a stakeholder, and it's in the best interest of all the employees to make sure the company does do well, and you can see that in what we do here every day. I think we all take pride in what we do. I think I've got InSync blood running through my veins, and many of us are in the same situation, we've got engineers that have been here 20 years, and we have very high retention and that helps, for certain product development, product sustainability, keep looking after old products and having that knowledge that goes right from day dot, across the board.
I'm sure you're brought into a number of support cases.
I'm quite a few times. It's like, oh, Lee will know.
If it's sold at the beginning of the company, then they'll come to you and say,
you will, yeah.
It's one of the things that I talk about with a number of people on the channel. If you have a company where not only people believe in the product, but also the company believes in the people, then you can have a lot of people staying for a long time. And that's only a benefit when it comes to onboarding new people, making sure the company culture continues. But at the end of the day, I guess, I don't know, what do you think is the most important thing to keep people happy and engaged with the company?
I strongly believe in a happy working environment where everyone just gets along. It's an open plan environment. If someone has a problem, you can just go and talk to anybody in the company, and we're all very approachable and always willing to help. And we don't put people on pedestals, Yes, I'm a director. I'm not seen. I don't like to be seen as that. I like to be seen as one of the engineers. That's how I like to see myself being seen as, and then become approachable. And that's what I want people, if they come, when we recruit people, they see that we're all in this open, and we talk together. And I think that's really important,
Yeah. You got to have the ability to have your own agency and talk and call things out. Was there anyone in particular that helped you along the way, and as a mentor, or just someone who was helpful that you kind of got on with?
Yeah, I mean Barry Flanagan. I mean he was my biggest mentor, I would say. I mean he recruited me at the very beginning in the Snow Wilcox days, and then took me on at InSync Technology when it was founded. And I've always looked up to him. He's always been a key figure in where I am now.
Nice. Well, it's important to have these people, and people who are in a position to encourage and invest a bit of their own time. It helps a lot, as we've seen here. I want to say a really big thanks to Fiona and Becky from Page Media, who do a really important job behind the scenes at Broadcast Focus. Keep all of these episodes coming out. And to thank them, and to thank Lee for his time with us. And please tap like and make sure you're subscribed. But with that said, just remains for me to say thanks, Lee, for your time. It's been really good talking to you, and appreciate your thoughts. Speak to you again soon.
Thank you very much. Thank you, Russell. Thank you very much.